This is section 3.5, equivalent statements and variations of conditional statements. So a couple of definitions. What we mean by equivalent compound statements, these are statements that are made of the same simple parts, so the same P, the same Q, and so on and so forth, and have the same truth values for all true-false combinations of these simple statements. So basically, if we put them on a truth table and we compared them side by side, our answer at the end would be exactly the same on every single line. The symbol that we use to indicate that two statements are equivalent looks like the equal sign with 3 lines instead of 2. Okay, so a 3-lined equal sign. We do need a property, and we've mentioned it earlier in the chapter, but again, we have a double negative property, where if you have 2 negatives, it's equal to the original. You can think of this as 2 negative statements, like negative, negative 1, and you end up with 1. It's the same kind of idea. 2 negatives undo each other. So you're going to have a few problems that just ask you to use a truth table to determine whether the 2 statements are equivalent. So what I'm going to do is I have these 2. I have first P or Q in parentheses or R, and then I have P or, and then in parentheses Q or R. That's hard to say. What I'm going to do is I'm going to find out the truth values for each of these. So I'm going to do this part first. So I have P or Q. So if I'm looking at P or Q, that will be these 2 columns. And remember with or, the only time it is false is when they are both false. So true, 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 and then the last 2 are false. Okay. So I've done that part. Let me do this part, Q or R. So again, if there are 2 falses, that's the only time I'm looking at a false answer. So there's our first false. And then the last one is also false. Those are the only ones that have no truth in there at all. Okay, so we've built up these little pieces. Let's do this one. So I have P or Q or R. So P or Q is here, or R. So I'm doing a disjunction with these 2, or these 2. And again, as long as we have at least 1 true, the answer is true. So they are all true, except for the last one, which is false. Now let's do the other one. P or Q or R. So that's this one and P. So this column and this column. True and true. True, true is true. True. At least 1 true. At least 1, at least 1, at least 1, and then the last one is false because they're both false. Now what we're asked to decide is whether these 2 statements are equivalent. So I'm looking at these 2, and if you compare them line by line by line and go all the way down, they are exactly the same. So therefore, these are equivalent. And this symbol is one we're going to be using quite a bit. It means therefore. Okay. One thing you might notice is that this is very similar to what we call the associative property in regular algebra or arithmetic. Now with arithmetic and algebra, we have an associative property when we have addition or multiplication. And what it says is A plus B in parentheses plus C is the same thing as A plus B plus C. And then the multiplication version would be A times B times C in parentheses, or A and B together, and then a C on the outside. Basically, it doesn't matter how you group them. If it's all addition or all multiplication, you can group them however you want to, and they're the same. Well, if you look here, these are all or, and here the first two are grouped together, here the second two are grouped together. So when it's all or, we have an associative property. We can group them however we need to do so, and it will work.